Several times during your life in school, you might have asked yourself, what do I need this class for? It's not like we see or even use this stuff every single day. In actuality, that's not true. By studying math, you can do everyday things like telling time, counting change, and making strategic decisions in one's work life. Almost every single profession uses some form of math. For example, nurses, engineers, bank tellers, pharmacists, and stock market analysts use math every day to perform their professional duties well. For example, by studying Spanish, you are now able to talk to and understand people who speak Spanish. With history, you are able to understand the events that happen to lead up to your life today. In fact, history is being made every single day. Those are only a minority of cases of what these classes can provide for you in everyday life, but you may still wonder, why do I need chemistry if I don't even use it in my everyday life? Why do we need chemistry if we don't even use the periodic table every day? We all need chemistry because chemistry is everywhere. It takes a huge part of your daily life as it is involved in your every action. Breathing, reading, or even cooking all has something to do with chemical reactions. Cooking brings about chemical changes in food. The texture and taste changes when food is cooked. Baking powder contains sodium hydrogen carbonate. This breaks down when heated, releasing carbon dioxide that helps cake mixtures to rise during baking.
Your daily routine may find you waking up in the morning, brushing your teeth, and then eating. This man is cooking grilled cheese, for example. But did you know that the simplest tasks, like finding the kind of cheese that is best suited for your grilled cheese, can be found in chemistry? No, you didn't, but now you do. Gouda or Manchego is the most suitable cheese according to the chemistry video series Reactions, which is hosted by the American Chemical Society. As a 3-minute video explains, these cheeses have the ideal acidity, or pH, for melting into a goopy mess. Now, cheese is made from milk, which is composed of 90% water. The remainder is lactose, which is a sugar, calcium, fats, minerals like proteins, like whey and casein. During the cheese making process, milk is curdled, removing much of the whey and leaving casein to help define the texture of cheese. Casein proteins collect into nano-sized spheres called micelles. These are held together by calcium and trap fats within their interiors. The surface of micelles is negatively charged, so these balls typically repel each other. However, curdling causes micelles to bump into each other, forming chains that trap water and aggregate into a gel.
Acid makes this clumping possible. Cheesemakers added bacteria and enzymes to milk that transform lactose into lactic acid.
Once cheese curds are formed, acid levels dictate the ultimate gooiness of cheese by relaxing the grip that calcium has on micelles. Cheeses with the acidity in the range of pH 5.3 to 5.5, such as Gouda or Manchego, make for solid melting according to this video.
But too much acidity can have an unfortunate consequence. Have you wondered why onions make you cry? Inside the onion cells there are some chemical compounds which contain sulfur. When you cut an onion, the cells break and those compounds suffer a chemical reaction, and they are transformed into more volatile sulfur compounds which are released into the air. These sulfur compounds react with the moisture in your eyes, forming sulfuric acid, which produces a burning sensation. The nerve endings in your eyes are very sensitive, and so they pick up to this irritation. The brain reacts by telling your tear ducts to produce more water to dilute the irritating acid. So you cry to keep your eyes protected from the acid.
Also, the food we eat has to do with chemistry. They consist of organic compounds like carbohydrates, starch and sugar, protein and lipids. Other nutrients like vitamins and minerals in water are all important chemical compounds. The process of respiration removes oxygen from the environment while adding carbon dioxide in water. Plants use these to carry out photosynthesis while releasing oxygen and water again out of their leaves. Plants apply a chemical reaction called photosynthesis to convert carbon dioxide and water into food, or glucose, and oxygen. It's one of the most common everyday chemical reactions, and also one of the most important since this is how plants reproduce food for themselves and animals and convert carbon dioxide into oxygen.
Phew! All of that cooking and talk about water might have made you quite thirsty. Grab a drink and put some ice in it. But wait, now that we have an ice cube out, have you noticed that it can melt? I mean, it's obvious that it can, but do you know why? When you melt an ice cube, you have a physical change because you add energy. Physical actions, such as changing temperature or pressure, can cause physical changes. No chemical changes took place when you melted the ice. The water molecules are still water molecules. No new substance is formed in the process, and this change is reversible. Water can be converted back into ice simply by freezing. A hydrogen bond is a weak bond that occurs between a pair of unbonded electrons from another atom and a hydrogen atom. Water molecules commonly create hydrogen bonds between one another. When the temperature is warm, the water molecules have lots of energy and they can move past one another as well as mix with each other. That changes when the temperature is cooled. In cooler temperatures, the water expels less energy and the hydrogen bonding takes place in earnest. Because of this, the molecules form an ordered crystal through the hydrogen bonding. This ordered crystal spaces the various molecules farther and farther apart. Soon they are farther apart than when they were a liquid, which makes the ice less dense than the water. The less dense object is always the one that floats, so ice floats in water. Density is the measure of the relative heaviness of an object that has constant volume. The volume of ice is also greater than the same mass of liquid water. Even ice simply floating in water can be explained with chemistry. Ice is less dense than liquid water. The heavier water displaces the lighter ice, so the ice floats on top. Chemistry also explains simple everyday questions of how things are or works. Have you ever wondered why the sky is blue? Is the color reflected from the ocean? Or is the ocean's color blue because it reflects the color of the sky? Well, an object is colored because of the light that it reflects. The white light from the sun contains all the wavelengths, but when it impacts on an object, some of its wavelengths are absorbed and some reflected. A clear cloudless daytime sky is blue because molecules in the air scatter blue light from the sun more than they scatter red light. When we look towards the sun at sunset, we see red and orange colors because the blue light has been scattered out and away from the line of sight. It might seem hard to believe, but chemistry deals with your emotions too. Chemistry is at the bottom of every step in a relationship. When we fall in love, our brain suffers some changes and also certain chemical compounds are released. Love is driven by these hormones: oxytocin, vasopressin, endorphins, and adrenaline. Emotions that you feel are a result of chemical messengers, primarily neurotransmitters. Love, jealousy, and envy all share a basis in chemistry. For example, when I come home from school, I open the door to see my dogs rushing at me. That's the adrenaline taking over. Then when I only pet one of them, the other one gets jealous while the one getting petted is being showered with love. This is all thanks to the chemical messengers. Oxytocin is the hormone stored in the brain. When the hormone is released in the brain, it results in feelings of attachment and bonding. If you look at oxytocin as we go down to the love chain, the molecules appear more complex, sort of like a love life.
In conclusion, the basis of chemistry is a very important part of your everyday life. Every single action that you do has something to do with chemistry. Whether if it's cooking grilled cheese, melting ice, breathing, eating, or just reading. Each of these actions are physical or chemical reactions. Even your body is made up of chemicals. Almost 99% of the mass of the human body is made up of 6 elements: oxygen, carbon, which is a third of our body, hydrogen, nitrogen, calcium, and phosphorus. Only about 0.85% is composed of another 5 elements: potassium, sulfur, sodium, chlorine, and magnesium. All matter is made of chemicals, so the importance of chemistry is that it's the study of everything.